Hi guys, today we are going to go over a way to solve systems algebraically, so doing actual math instead of graphing. This method is called the elimination method. But first, before we try a problem and I go into the steps, let's see what a system of equations is. So what is a system of equations? A system of equations is when we have two or more equations with multiple variables in a single problem. So that means we have two equations now compared to just one equation. With the elimination method, let's figure out what elimination actually means. So think about, what does eliminate mean for you? If you said like it cancels out or getting rid of, then those are types of elimination. Some people say elimination means we take it away. Okay, so what we're going to do is we're going to cancel these out or get rid of or take away one of our variables. This next slide here shows the steps for the elimination method. Our first step, what we're going to have to do is we're going to have to multiply equations. Sometimes we may have to multiply one equation. We may have to multiply both equations. Or sometimes we get lucky and we don't have to multiply anything because something cancels out. But when we do have to multiply, we want to see what letter or what variable we can eliminate. Now we want those to have the same coefficient. That means we want it to have the same number that's in front of the variable, but we want one to be positive and one to be negative. After we figure out which one we can eliminate, we have to add those equations and then solve for that variable that's left. Once we have that variable, what it equals, we'll take that, plug it into one of the two equations to solve for the other variable. And last but not least, we need to write our answer as an ordered pair. So let's try one, solving using elimination. What I would do is I would look up and down. Look at your x's. Do these x's cancel each other out right away? That means, do they add up to 0? In this case, no. Look at your y's. Do 3y and negative 9y, do those add up to 0 right away? No. So now we're going to have to multiply one or both of the equations. You just decide which letter, which variable you want to get rid of. For me, I'm going to look at my y's and see if I multiply this top equation by 3, then that would make this a positive 9y. 9y minus 9y, those would add up to 0, so those would cancel each other out. So what I'll do is I will multiply the top equation by 3. Now I'm going to multiply all three terms inside that equation, inside the parentheses. So I'm going to distribute that 3. 3 times 3x is 9x. 3 times 3y is 9y. 3 times negative 15 is negative 45. From here, I'm done with using this equation. So now I'm done with that. I'm going to focus on these two equations here. I'm canceling my y's out. So now I combine my x's up and down. So 9 plus 5 is 14x. That's going to equal 3 minus 45, which is negative 42. At this point, it's a one-step equation where I have to get the x all by itself, so I'm going to divide by 14. So those 14s are gone because they've simplified down to 1, so x equals negative 42 divided by 14 is negative 3. I have my x variable now. Now I need to solve for my other variable, which is y. So I can plug negative 3 into my original first equation, the second equation, or I could plug it into that equation that I changed. I'm just going to plug it back into the first equation. So 3 times negative 3. I'm plugging negative 3 in for x. At this point, it's a multi-step equation. I'll multiply, so negative 9. Now I have to take the right steps to get y all by itself. So I'd add 9 to both sides. And then divide by 3. Now I just need to write my answer as an ordered pair. Remember, x always comes first. So there's my ordered pair, negative 3, negative 2. Now what you could do to check that is to plug negative 3 and negative 2 back into those two equations to make sure that it made those equations true. Let's try another one. 4x plus 3y equals negative 2, then x plus 5y equals negative 9. Look at your x's. Can you cancel anything out right away? No. Look at your y's. Can you cancel out anything? No. So now you have to decide if you're which letter you're going to get rid of, which variable. If I'm looking at my x's, all I'd have to do is multiply this bottom equation by negative 4, then that would get rid of my x's. So I'm going to distribute negative 4 to all three terms inside the parentheses. Negative 4 times x is negative 4x. Negative 4 times 5y is negative 20y. And then negative 4 times negative 9 is positive 36. Once you've distributed that, you're done with this equation. Don't use it. Now combine your first equation and the one that you've changed. So your x's are going to cancel each other out. 3y minus 20y is negative 17y. Negative 2 plus 36 is 34. Now it's one step to get that y all by itself, so I'm going to divide by negative 17. So y equals negative 2. I have my y, I need to find my x. So think about what you can do to find your x. If you're thinking that you can plug negative 2 into one of those equations for y, you're correct. I'm just going to plug it back into that first equation. 4x plus 3 times negative 2 equals negative 2. It's a multi-step equation, and you're going to solve for that variable x. I could have plugged it into that second equation or the equation that I changed. It does not matter. So 4x minus 6 equals negative 2. There's going to be two steps. First thing I should do is move this negative 6, because you have to get the 4x all by itself before you get the x all by itself. So I do the opposite of subtracting 6, which is adding 6. So I have 4x equals 4, then divide by 4. X equals 1. Write your answer as an ordered pair, 1, negative 2. Remember, x always comes first. If you want to check it, plug that back in. So plug 1 in for x, plug negative 2 in for y. Plug it in back into both equations and see if the left side of the equal sign equals the right side. You're seeing if it makes it true. Let's try this one. The x's do not cancel out right away. Neither do the y's. So now I'm thinking, what can I do to get rid of a variable? Well, I'm going to multiply this bottom equation by 4, because then that would make my x on the second equation negative 8x. So they would cancel out. So I'm going to distribute. So negative 8x plus 12y equals 52. Sorry. So I'm done with that second equation. Combine my x's, those cancel out. Combine my y's, so I have 14y equals 56. Divide each side by 14. So y equals 4. I have my y, plug that number in for y into one of the two equations, or one of the three. It does not matter. I'm going to choose that first one. 8x plus 2 times 4 equals 4. So 8x plus 8 equals 4. Subtract 8 from both sides. So I have 8x equals negative 4. Divide by 8. So x equals negative 1/2. So there's my ordered pair. Negative 1/2, 4. Let's try one more. Look at these two equations. Your x's do not cancel out right away. Neither do your y's. Now if I'm looking at these, I'm going to have to multiply both equations. So decide which letter, which variable you would like to get rid of first. Well, 3x and negative 4, the closest number that 3 and 4 multiply to is 12. So I'm going to multiply the top equation by 4 to make that 12x. I'm going to multiply the bottom equation by 3 to make that negative 12, because then they would cancel out. So 4 times 3 is 12x. 4 times negative 6 is negative 24y. 4 times 9 is 36. Now distribute the 3 to the second equation. 3 times negative 4x is 12x, negative 12x. 3 times 7y is 21y. 3 times negative 16 is negative 48. The x's cancel out. So now I combine my y's. I have negative 3y equals negative 12. Divide each side by negative 3. So y equals 4. Now take 4, plug it in for y to one of the first two equations, or you can plug it into the second two that you've changed. Now granted, you'll have bigger numbers there, so I would plug it into one of the first two original equations. I'm just going to pick the first one. It doesn't matter which equation I would have picked. So 3x minus 24 equals 9. Add 24 to both sides. So you'd have 3x equals 33. Divide by 3. X equals 11. So write your answer as an ordered pair. 11, 4. Remember, x always comes first. In the first three examples, we only had to multiply one equation. In the last example, we had to multiply both. Sometimes you may have to multiply both equations to be able to get rid of one of your x, to get rid of your x's or to get rid of your y's. It doesn't matter. There's a lot of ways that we can do this. So hopefully this will be a good give you a good start that will help you with the homework. Have a good day, guys.